All right, that's recording now. All right, we're good. All right, so probably left off question 17 last time. 14 frame review. So now we'll move on to question 18. What is the molecular geometry of SF6? Anybody have any idea? That's all it's called.
Draw it out.
You have to draw it out.
Yep. So go ahead and draw it out.
It's up to
Somebody-
control. Right?
Is it though?
I think so. The one I showed you, Davis. Huh? No.
No, I think it's with a certain doctor that she's missing something.
Yeah, I think so too.
Yeah. Raise your hand if you all have answers. I with pride. Few more seconds.
You're trying. I think it's cold. LOL.
All right, what do I get for the answer? Octahedral. All right, so let's confirm that. So sulfur, right? 6 valence electrons. Chlorine 7. So 7 times 6 is 42 plus 6 is 48. Well, let's use the trick.
I already worked out.
So you do 6, right? Because that's the number of terminal atoms
Yeah.
times 8. And then you'll get 48. So if you do 48 minus 48, you can confirm that there's no lone pairs on the side of the line. So then you'll draw it out. Sulfur,
I
chlorine,
gave him it.
green, 6 fluorines. Draw that out.
Just like
So how many electrons did that use up? 2, 4, 6, 8, 10, 12. 12.
it's crazy.
And then all of these fluorines, right, they need 6 to be satisfied. So that's totally. So some of y'all might be thinking, Rich, the sulfur can't have an expanded octet. And the answer is it can. Because anything like, how I think about it is anything phosphorus and above can have an expanded.
Phosphorus and above.
Like under, like physically
Yeah,
under,
the-
physically
the-
under.
The number is figures, that's why I said above. So yeah, so since there is 6 things attached to this sulfur, right? So there's 1, 2, 3, 4, 5, 6, and they're all bonds. You can conclude that this is octahedral. And y'all would know that as well if you memorized the chart. All right, so that is 18A. Questions about that?
It just sounds like it would be.
Good.
Yeah.
All right, cool. We're on to 18B. True or false? Trans isomer of molecules.
Oh, yeah, it's cis. I agree.
Because this they go in different directions.
Yeah.
So the dipoles are going in the same direction.
Yes.
So Michelle also says false. Why do you think it's false, Michelle?
I'll just say it out loud. I remember whenever you had talked about it beforehand, I've memorized that trans was the non-polar one and the cis was the polar one.
So here's the thing about memorization, right? I mean, that's good that you got the answer right, but you want to be able to understand concepts, not just memorize. So let's look at something like this. So this is cis isomer, and this is the trans isomer. These are the exact same, right? Except one thing is this chlorine is on the same side, this chlorine on the other side. So this one,
This is.
The left.
this one is cis, this one is trans. Yeah, but the important thing is you realize why it's false. So chlorine's electronegative, right? So it'll be pulling electrons from this carbon. So it'll be a dipole that way. And then chlorine, right, is also electronegative, so it'll be pulling in the same direction. You can kind of think of those as like the same force. I say, for example, you have a 5-year-old and a 5-year-old on one side of the tug of war. They'll both exert equal strength. Assuming this 5-year-old didn't take like steroids or something, you have 2 5-year-olds pulling at something in the same direction. So with that, you can say that the trans isomer will be non-polar, since both of the dipoles will cancel out. Whereas if you look at cis, there'll be one dipole this direction, one dipole this direction, making it a net dipole down. So since there's a net dipole downward, like if you draw out your vectors and stuff, like it's as if like you have on this side, you have a 5-year-old and like a pro bodybuilder. They won't exert the same amount of force. So for cis, they have unequal dipoles, unequal sharing of electrons. Whereas for trans, they're both equal since they're both going in like the direct opposite direction.
For something to be considered cis or trans, does it have to be the same atom or no? Well, like what if you have a carbon on one end, or not a carbon, let's just say like a sulfur on one end and the chlorine on the other.
So if you're saying like sulfur on one end, chlorine on the other,
Yeah.
that
Would
would
it still
necessarily
be cis and trans, or would it still be non-polar if it was trans, or would it?
now, no. But when you get to OChem, you'll realize that certain stuff have stereochemistry. So like one will have like this sulfur, for example, will be on a wedge and the chlorine will be on a dash. So in that, like, okay, let me draw one.
Wait, so no matter what, in this class, if it's trans, it's always gonna be
Why are you
non-polar.
doing no? I mean, wait, no, because we did cis and they were non-polar.
Cis?
Yeah, because the bonds are not, you have to look at the bonds. If the
There's
bonds are
only one
polar,
double bond.
it's okay. You all worry about
No.
that. You have to look at like the bonds, like if it's an
Oh,
iodine. You know what I'm talking about, Rish? Because we did a cis. We did a cis thing, but it was CH3 and H on the bottom. Since all the bonds are
Or non-polar, then yeah, the
Yeah.
entire thing's non-polar.
Yeah.
Yeah.
But it's like.
You drew it like that, you drew it like this.
That's not cis.
No, because this is where I got stuff.
This is when you're talking about like the same, for this class, it's the same situation. But if you're like, Tomer, this is what I was talking about before, with like the sulfur and the chlorine, you could have like one sulfur on a wedge, so it's facing out, and then a dash, so it's going into, the chlorine's going into the board. In that case, it's trans.
Okay.
This technically is considered trans, but like for this class, cis and trans are usually gonna be the same. It's gonna be the same substituent.
Yeah, I got that question
Well,
wrong.
it's,
Like it's cis, but it's still non-polar because the bonds are.
this is not CH3.
Oh, are you talking about something like?
Cis is-
No, I'm talking about something like this, where you have CH3 like that, and then another
Yes.
CH3.
Uh-huh.
That's CH3.
And then you
but
do
two
two
carbons
lines,
and-
yeah, that would still be like, that would still be non-polar, right, even though it's cis.
Yeah,
But you'd have to continue the whole molecule, like that's like the most reduced version of the molecule. If you were to add the carbons, and then you'd realize you need to add 3 more bonds to each carbon, so it does cancel out.
Alright, so you're saying draw this out.
But no,
Oh my god, you're.
Alright, Tomer, this is the full,
the whole thing, so it cancels each other out.
this is like the full thing.
Yeah, but you don't need to, you don't need to draw it out to know.
Alright,
that.
if it's the-
You know that it's
Yeah.
But if it's like, if you draw it out fully and then you realize it cancels out, wouldn't that mean it's non-polar?
Yeah, that's what I'm saying.
Yeah.
If this is carbon, not CH3, would that be
I
like?
could figure this out. It's not gonna have like polar. Not to connect.
Oh.
You're saying this?
Yeah.
Yeah, but like the carbon would have to be connected to something. Like, you can just have a regular.
I know what.
That's possible. And then, Rish, I had another question. We had an example, I'm sorry, that we had another example and it was like, so if you took that entire CH3 out on, no.
No, wait, I'm just gonna make it.
Okay. So it's a trans isomer, but the thing is, one of the atoms, instead of being the other atom, is like iodine. No, it's not like iodine, it's like chlorine.
Oh, this.
So that would be polar, right? Yeah, and then you put an H down here. Spoiled
down there?
ass.
Like that?
Yeah, it was something like that. Yeah, that's why I was.
Yeah, exactly, that would be. Because the chlorine would push electrons over here, but then the carbon hydrogen bond is non-polar, so it doesn't really matter. But even if it was like carbon and oxygen, it would still be considered
But
non-polar.
if that
Or,
if the
sorry.
chlorine was iodine, then it'd be non-polar, right? Because C.
Yeah, because C and I have the same electronegativity. So it's something to memorize. All right, but to answer the burning question, the trans isomer of a molecule is considered polar, that's false. Right, moving on.
I am not with that. I'm
All right.
like.
True or false? Xenon tetrafluoride has the same electron geometry as it does molecular. How can you tell?
I'm like yours.
How do you know that?
Square planar.
Are you?
Draw it out. Yeah, first one is Lily and second is Brandon.
Square
Oh,
planar,
yeah.
right?
Let's see, that's work,
It's non-polar.
and then you do 7 and then 8.
Actually.
Let's use a trick. 28 plus 8 is 36. Then let's use a trick, so 4 times 8, 32, because we have 4 terminal atoms, and then we have 8 multiplied by 8, that's 32. So it's 4, and then we divide it by 2, so we have 2 lone pairs on our central atom. So let's draw it. Xenon, boom, 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 connect that fluorine, like so, just connect all our fluorines. Then right, we use up a total of 1, 2, 3, 4, 6, 8, 10, 12 electrons, so we're gonna do 20 electrons now. And then these all have to be satisfied, so we're gonna put both pairs all around these. No, it's not 30, wait. 2, 4, 1, 2, 3, 4, 6, 8, 10, 12. 36 minus 12, that's 24. And then now we're gonna go put it everything around. So yeah, 24 minus 24 is 0. So. Anybody answer out, what's the electron geometry of this molecule? Electron geometry? There we go. So this is octahedral,
You know the shape.
hedral.
Sorry, guys.
Interesting. All right, and then our molecular geometry, what's that gonna be?
Square planar.
Square planar. SQ, I'm gonna write SQ planar.
Good job, Tomer.
I did my question.
So proud of you, Tomer.
All right,
Yeah.
so what's the correct answer to this? Is it true or false?
False.
Let's see.
It is indeed false. Because as you can see, there's 2 different electron geometries from octahedral to square planar. Any questions about that? All right,
Yes, I think.
now number 20. Use Vesper theory to predict the molecular geometry of SO3 minus.
1-1.
All right. Let's see, Tomer. Come up to the front and draw this.
You can bring your paper up if you want to say.
No,
again.
no, I want to test this.
Okay, good. See, this is excellency right here. This guy. Everyone, if you just want to watch the World Cup, you can raise your hand.
Wait, what are you talking about?
You just want to watch the World Cup instead of learning chemistry, we can do that.
So you want to find the number of valence electrons.
Dang, Tomer's teaching? This is lit.
And then, no, S, you got 1 S.
Actually, you talk loud so that
1,
people on Zoom.
and then sulfur, you got 6 plus, right? 3 times 6 for the oxygens, and then you have these 2, so you're gonna add 2 more. So 18 plus 6, 24. And 24 plus 2 is 26 valence electrons. And then you know sulfur is gonna be your central atom.
Okay.
So you have the sulfur, and it's gonna be connected to 3 oxygens. 1, 2, 3. First, and 26 minus 6, you have 20. And then you want to put the lone pairs on each one. And then you're left with subtract 18. And you have 2, so you're gonna add 2 on sulfur. And then you know that it can't be trigonal or triangular planar because you have the lone pair above that sulfur. So it's gonna push these oxygens back down and it's gonna be triangular pyramidal. Right?
That is true.
That's correct.
Yeah.
It is?
Yeah.
Yeah, but just do your formal charge on, so, because you remember the amount of, the number of minus charges tells you how many single bonded oxygens, right? So if there's only 2 minus, that means one of those oxygens needs to form a double bond.
A double bond?
So you can erase like a lone pair on one of them. And add a double bond there.
But it wouldn't change the electron.
It wouldn't change
The molecular geometry.
it wouldn't change the molecular geometry or electron, what is the electron geometry of this?
Wait, why did we add a double bond?
Because of the formal charges. His formal charge always trumps octet.
Yeah, but it doesn't matter, it doesn't change the answer.
So wait, how do you know when you need to do a double bond?
So remember the charge on sulfite, so SO3 2 minus,
2 minus.
the number of minus charges or negative charges tells us the amount of single bonded oxygen atoms.
Oh, okay.
So if it's SO3 2 minus, that means there's two single bonded oxygens. But that only applies for certain things, because nitrate is different. You can't exceed the octet on nitrogen,
Oh.
so that's why NO3 minus doesn't tell us.
Okay.
Oh, the same thing with the bottom one too, right? Because it's CO3 2 minus.
Exactly, yeah.
Just remember that the charge number, charge tells you the number of single bonded oxygens. So real quick, in the case of carbonate, right, you do your same thing, so 2 minus, so you need 2 single bonded oxygens. So you do something like this. And then let's say this one needs a double bond, so draw out your structure. Minus, and then, so what are the bond angles?
120. So there's nothing on central atom.
Why is it 120?
I'm gonna be confident. You know what?
I mean, you've got 3 to go around, it's flat, so you have to go 360. 360 divided by 3 is 120.
How do you know it's flat?
There's no lone pairs on the central atom.
What's the molecular geometry of this?
Trigonal planar, no?
Trigonal?
Trigonal?
Planar.
Trigonal? You're right.
Yeah. Wait, so I'm confused.
I'm trying to ingrain this in your mind. Trigonal?
Planar.
Yes.
And so trigonal planar, right? So it's flat. It'll be flat on the page.
Oh, the chemistry really is beautiful. Wow.
Always STEM majors.
All right, yeah, so the correct answer is C, 120.
He says biology is beautiful.
It is beautiful.
I agree with you, Ash.
All right, how many sigma and
Biology
pi
is a
bonds?
STEM major?
I know.
All right, next question, how many sigma and pi bonds are present in the polymer?
You cut part of the molecule off, no, that's not good. Oh, these
3 sigma.
Aguilar kids really trying to get in
1
there.
pi. Oh, wait, there's more sigma.
Yes, I agree with Audie.
3, 6. 9.
Wait, let me not write that.
Mind your way,
Yeah.
I'm so sorry. Excuse me,
There we
excuse me.
go. Bonds and 1 pi bond. I got E.
They're basketball pieces.
I indeed got the first letter of the word elephant.
He's probably lost.
No, Diego never gets lost.
He's
Just
no, he
another
probably like
health
redistricting.
Another health risk.
Yeah, he's like lost in my life.
So how many sigma bonds are there?
Love it.
Okay, so we got some people saying 11.
You got 3 right here for this carbon hydrogen bonds. You got 1 for this carbon carbon bond,
Where is he?
1 for this carbon hydrogen bond, 1 for this other carbon hydrogen bond, and then 3 here. So 3 plus 1 plus 1 plus 1 plus 3. That is indeed a total of 3, 6, 7, 8, 9, and then there's 1 over here. So you count that out. 3, 6, 7, 8, 9, 10. You got 10 sigma. Or remember. But what about this double bond right here? What do we
It
do
has
with
1
that?
sigma and 1 pi.
1 sigma, 1 pi. So that's 1 sigma and then 1 pi. So that's 11 sigma. Let me draw this symbol. So y'all can see this. 11 sigma and pi. The correct answer is indeed the first letter of the word element.
The element or element?
Element and element.
Okay.
Right. Questions about that?
So are these two?
Right, on to 23. What angles are associated with the central atom that's tetrahedral electron geometry? I'll just say on this. Just a straight memorization.
No, yeah, I have it. I don't know. Can I say it?
Yeah.
A.
Yeah, it is a 109.5.
Oh, yeah.
It's like it looks like a virus, right? And it's got like 1 coming up and then 3 on the bottom.
Yeah.
Okay.
It's not very true.
So when is it when there's 4 flat ones? Like 4, like it's like a flat
Like trigonal, or no, what is it, square planar?
square planar?
Is that what you're talking about?
Yes.
Wait, square planar? Yeah.
Yeah, because you remember.
When there's two lone pairs, right?
Two lone
Yeah.
pairs, yeah. So what is the electronic geometry for square, so for something that has square planar molecular geometry? Octahedral, right? So square planar can only be applied if you have 6 electron dense regions around it. 2 of them being lone pairs, right?
All right, yeah, so the correct answer, or this, I don't know. The correct answer is 109. All right, moving on. Electron geometry in the central atom of PCl3 is what?
I agree.
Michelle says C. What do
I
you got?
agree with Michelle.
All right, Tomer agrees with you, Michelle. We got the Sadegi students on the same team here.
All right, let's draw this up. 7, 5, 21, 26.
We should do another good one for the finals and like do it versus like Sadegi versus Armand students.
Oh, yeah.
They,
Nice.
I think they win.
Oh, yeah, you have Michelle, you have Kristen, you have Tomer, your Tomer.
26 minus 6 is 20 electrons. Then we need to do the whole roundabout thing, so 6 more for these chlorines to be satisfied. But wait, we're still missing 2 electrons. Where do we put those on top of the phosphorus? So yeah, we have all this, so yeah, the correct answer is indeed E, trigonal bipyramidal.
Huh?
Good.
Not tetrahedral? Electron
Oh,
geometry.
electron geometry, oh, not bad. I thought it said molecular geometry. The other one confused myself, yeah.
If that was the case, it would be trigonal pyramidal, not trigonal bipyramidal, right?
Yeah. Bipyramidal is the other one.
Yeah, it was like more.
So I see how in the chat that Michelle says something like she just started learning about angles today. And if you are just starting to learn about something today, you should probably start studying everything on your own, just because like for me and Rich, we haven't even touched on chapter 11 or 12 for OChem. But that's all going to be on the final, and we only have 2 class periods left to get through chapter 11 and 12. So we're actually gonna, like, me and him are gonna start studying it on by ourselves, because we know that, you know, you can't just wait for them to start teaching it in class, you know? Yeah, good job, Michelle. Exactly. So make sure you're doing all these problems ahead of time, so that way in class you can ask questions and it makes sense, hopefully by the time Professor Sadegi starts teaching it. But yeah, that's all, a little piece of advice that I have.
Why do I have to do all this? It's just.
Label the hybridization, we'll cover this the other day. Label the hybridization at carbon number 1, 2, 3, and 4 in the molecule.
Michelle got her money yet. Sadegi always wondering why she's 2 steps ahead.
There should be a double bond right here.
Oh, you're adding another double one?
No, there should be a double.
Oh, yeah, I was thinking that. Oh, I added one.
Oh, in the chest.
Oh, yeah, well, that's because somebody's always.
Just 2 students.
He was a Georgia student.
They left because I told them to be quiet. Because they were saying.
Their friend is outside. I know. I see my friend on my stream. You can't clown on.
All right, what do you think, Tomer? What did you get?
A.
Tomer got A. Michelle, what did you get? You think Michelle's a follower, or is she following because she also got the right answer? Is A
I'm sorry, I got B.
Oh,
yeah.
B.
interesting.
You got 1 for A, 1 for B. Let's see what's this right. Tomer, let me ask you a question.
Let me look at it again. Sigma and pi bonds. No, you add the sigma bonds and the number of lone pairs to get your hybridization.
Yep, indeed. So
I think
so for sp3d, right? sp3d hybridization, how many total?
5.
Yeah,
on that
5
one.
electron double.
Yeah,
And get carbon have 5 bonds.
no, that's, I just noticed that.
Yeah, so carbon can't have 5 bonds, so we can go ahead and cross this out. That's fine. So let's take it step by step. Hybridization of carbon 1. So we got 2 things attached. 2 things attached is what hybridization?
SP.
SP, exactly. So this is SP hybridized. Because it's SP hybridized, we can go ahead and cross out D. Now so we get carbon 2. Again, there's 2 things attached. What hybridization is that?
SP.
Yeah, and at this point, we can go ahead and circle option B. But let's go ahead and go the full 90 yards. So carbon 3, there's 3 electron domains. How many, well, what hybridization is that?
SP2.
sp2, exactly. And then we got carbon with four things attached. What is that?
SP3.
Exactly. So our correct answer is B. Right. Any questions about that?
He's the number of. Yeah.
Oh, you mean the A, X, E, whatever?
Yeah, that.
I mean,
Like.
people used to like remember stuff. I'll never do that online.
Oh, yeah, I've never used that, but like where X is the amount of lone pairs or something. Yeah, I remember looking at that and it kind of confused me. I just kind of started memorizing all this stuff.
Yeah, I don't know if it's trouble. Draw it out and then do this.
Yeah, what I memorized is all the electronic geometries and then all the molecular geometries that apply to each one. That's the easiest.
Yeah, that's what I'm gonna do. Yeah.
It's still on 26.
You have plenty of time still for the exam.
That's crazy.
So make sure you're studying, don't waste your time. Got it. Yeah, you still need to do that. There's a lot of practice. What, did you do all of them?
No,
There's a lot in the back.
Oh.
Stuff that you gotta do.
Wait, was that in the second one?
Stuff. All right,
What's the answer?
which ones?
All right, question 26. Which statement best describes ionic bonding in lithium? This is an interesting.
What is this?
number 26.
Okay, if there's an exception, I got it wrong. That's what
An
I'm
electron
thinking.
is transferred from lithium to the chloride? Oh.
But like it's ion, but the ion.
D, for sure, yeah. It's D.
I don't.
Because we did an assignment about this, right? And I said the transferring it was wrong, and it's actually
All right,
electrostatic
Because
attraction.
you're so confident, explain why.
Well, I don't understand it now.
I'm just saying.
Hold on, everyone listen to Audie. Audie's, put the spotlight on Audie, hold on.
Yeah, you're right. Wait, lithium is positively charged, fluorine is negatively charged, and there's electrostatic attraction between the two of them. They form that crystal lattice.
Why is there electrostatic attraction?
Why?
Why can it be like transfer of electrons? That's what ionic bonding is.
The transfer of electrons isn't what holds them together. I don't know why.
Wait, one more time.
Can you repeat it, Lord?
Yes, okay, so question or answer, what is it? Answer, so I would assume that most of y'all were between A and C and D, yes. So let's see why C is not the right answer. So it's talking, it says an electron is transferred from a lithium atom to a fluorine atom. While this is true, right? This is obviously true. It's the definition of ionic bonding is the transfer of electrons. But the actual bond is due to electrostatic interaction, not the transfer of an electron. The transfer of an electron gives rise to your positive charge, you know, your cation, and then the one that's gaining it, your anion, which is the negatively charged, right? That causes, the transfer of the electron causes those charges to be imbalanced. And once those charges are imbalanced, they start attracting each other. And that
But there is still a transfer of electrons?
there's still,
Okay.
That's the very definition of ionic. Like,
Yeah.
you can't have ionic bonding without the transfer of electrons.
but the actual bonding is between the like negative and positive charge that pulls them together. So it's the electrostatic
So
force.
there is a bond?
It's more of like a force.
Like,
Have you ever heard of like Coulomb's force?
yes.
Yeah, so like F is equal to K Q1 times Q2 over R squared, where Q is the charge of whatever, so he's writing it out right here. So Q1 is the charge of the first species, Q2 is the charge of the second one. And it's basically a force that's attracting them, so this electrostatic force between the two ions.
But it's not due to the electron.
So that force is a result of the imbalance of charge, which is derived from the transfer of electron. But the actual, once that electron has been transferred, it's not being transferred back and
Yeah,
forth.
no.
It's between the negatively charged fluorine or fluoride and the positively charged
Is it
lithium.
attracted to like fluorine more than it is to lithium?
Is it, wait, what did you say?
Wait, Never mind, I understand it, yeah.
So yeah, remember fluorine being the most electronegative is gonna wanna pull that electron from lithium. So it actually takes it out of lithium. And then you have a positively charged nucleus. And then a negatively charged fluoride ion. That is both being attracted to each other. And that's the electrostatic attraction that exists between the two ions. It's the actual, which is what describes the actual ionic bonding. Yeah. I know when I first saw this question, I was like, oh, this is a tricky one because you can think C, because that's the definition of ionic bonding. But what's actually keeping them together, and like what we see in a crystal lattice, is the positively charged is attracted to the negative charged ions.
That calls it like the like rigid.
Exactly.
Right, so any questions on that? All right, moving on to 27. I believe somebody wanted some practice for the final. This is exactly, we got this from the same source that makes the finals. Think of that way.
I just know the Jordan guy. I don't understand.
Oh, it's reacting. It's reacting.
Yeah. Thank you.
Oh, wait.
Because look, it has a bond. It has a bonds broken.
Like 8. Yeah.
Products minus reactants. For that one, they give you like the entire compound, like for example, they give you the. combustion of bond.
Oh,
But this one, they gave you just. the bond. A bond break.
Wish I could say thanks.
Wait, I was about to put you.
Actually, warmer than
Big and warm.
Yeah. Why?
Warm or chill, which one?
Okay, like chill vibes,
Oh.
like warm weather.
Warm, oh.
The girl. Don't say girl. But yeah.
I mean, people have said it goes. Wait, so you go to use.
I'm gonna just call her.
How did that go to Stanford?
Jordan guy.
Hey, Matt.
Why can I call him
You're
Jordan?
big, right? Oh, okay.
Yeah, why?
Because I had
Okay.
some food earlier, Indian food.
I really can't call him Jordan guy.
I don't know if you're. God, you call it Jordan. You know.
You know.
All right. You got an answer?
Come do the math, I'm already in.
Keep
You mental
pushing.
math. Give me a few seconds.
Exactly, a few more seconds.
Thank you.
Oh, wait, Tomer, you have the answer, right? Okay, when I'm done, I'll.
You could be wrong.
I mean, the point is, excuse me.
Michelle had gotten an answer.
All right.
Oh.
I know, because there's.
You get an answer.
Oh.
Every person. That's above the.
Okay, I got it. Negative.
That's your
one,
point.
zero,
You're a G.
5. He's like, how do you know about Jordan guy? I was literally on an answer talking about Jordan. Actually. Oh, bro, this is something right. I'm just joking.
Warm minus bonds broken.
Bond to that.
Take
Wait,
your product.
bond broken, it's reactants minus product. Yeah, I don't.
Really? Yeah. Okay, well, I have it backwards.
Okay,
Okay, as long as you make the mistake now.
Yeah.
that's fine.
That's crazy.
Okay, and I'm gonna bring these.
All right. You want to start working out, Rich?
Oh,
do it.
got it. I'm just saying.
That Rich got competition, right?
Yeah. I like it.
Oh, okay, my competition sounds like this. Not really competition.
Are you gonna find your way out? He's gonna find his way
Want to
out.
start working it out?
You're gonna find your way out.
Wait, do you need help getting out?
Bye, Diego. Really? What do you want to Oh, at that time, are you serious? Oh, I
All right,
saw you.
anyways, let's do our formula.
Bye, Diego.
So delta H, right, equals sum of bonds broken minus the bonds. It's basically a fancy way of saying reactants minus products.
But don't get this confused with the pizza formation, right? the ether formation where you do products minus reactants.
Yeah.
You don't want to get that confused with that, or this confused with that.
So, right, you do your little fancy stuff, so. No, they were nice and they gave us the Lewis structure of ethanol, which is right here. So how many CH bonds are in ethanol?
5.
So we're gonna do 5 times 400. Times 100. Then we're gonna add on another, how many carbon oxygen bonds?
1.
Yeah, so 1 times 358, or just 358, and then how many oxygen hydrogen bonds? So yeah, 463. That's for one compound. Now we gotta do oxygen.
And then carbon bonds.
So how many oxygen double bonds?
Wait, for that one, did we do like carbon bonds, 348 plus 349
Wait, which one?
for the ethanol or
Between the
whatever?
2
Oh, yeah, we did.
But you
Carbon
did-
carbon bonds,
Yeah.
348.
358, and then there's also.
Mhm.
That's one compound. Now we gotta do the oxygen. How many are there?
There's 3.
Yeah, but oxygen has, yeah,
There's 3.
there's one oxygen.
Three double. Yeah.
Okay.
Bless you. Okay,
I thought this was.
so do we do 6 or 3,
3.
right? Because we have, go ahead. Someone.
So it's oxygen, and then double bond.
So there's only one, yeah, there's only
Yeah.
one double bond, and there's 3 of those, so
I have a question.
3 times 95.
Like,
So,
it might just be a dumb question, but
so.
This is the reactants.
You draw the Lewis structure.
I did, but you can make another bond.
He wants to know why is O2 a double bond?
Oh, why is O2 a double bond?
There's
Okay. So let's say hypothetically, we made this a single bond. So now what would our Lewis structure look
You
like?
would find,
Something like this.
You a triple bond?
I mean, yeah, but let's do that too. Let's have a charge on oxygen.
Oh,
It's gonna be +1 on that one, it's gonna be -1 on these 2.
So you want a
It's-
+2 or a -2 charge? You don't, right?
Yeah.
You would want an overall charge of 0 to be the most
If we
stable.
do this,
you wouldn't?
You would want.
Yeah, okay.
and oxygen also likes 2 bonds, so the forward charge would be 0.
How many bonds does nitrogen like?
3.
So N2 has how many bonds?
3.
It does.
I mean, a lone pair, right?
And silicon.
Silicone?
Silicon.
Wait, silicon has 3 bonds, what?
No, it just likes 3 bonds, but I've never seen that happen, so I don't even know.
What?
Silicon, a group 4 element, like 3 bonds?
No, oxygen, yeah, silicon, phosphorus,
These are 2 different groups.
nitrogen and phosphorus, like.
Yeah.
There we go. Carbon and silicon like.
You gotta put the periodic table as your lock screen.
No, I'm not gonna become real.
You don't wanna get an
I'm a bio major.
You talk.
Yeah, you're right.
We're the real STEM major.
Right here.
I have a.
So minus the bonds,
All right, minus the bonds formed. So how many carbon oxygen double bonds? we got?
2.
6.
Wait.
Where am I getting 4?
Yeah, it's 3.
There we go.
Yeah.
Oh, that's what I meant,
Three double
sorry.
bonds and then these. 4 times 799.
Wait, no,
And then
I got the right answer.
what about oxygen hydrogen?
Sorry.
All right, anyways, how about the oxygen hydrogen? 6 times 463. All right, now we basically solved out this entire monstrosity calculation and we should get our final answer.
and what did Audi get? Audi, what did you get? And B happens to be, well, if you're gonna be wrong, you might as well be. I'm just kidding, you're right.
Wait, it's right?
It's right.
Thank goodness.
All right, yeah, negative 1255 kilojoules. That's correct. All right, got time for a couple more. Ethanyl estradiol, or EE, is widely used in never mind. Which arrow points to the shortest carbon-carbon bond?
D,
It is.
yeah, she's
I
right.
agree.
Why is it D?
Because it's a triple bond.
As
And they're like
sigma
are
bond
holding
and
each
two
other
pi
tight.
bonds,
And
and
then
pi bonds are very strong.
so
This looks like an interesting alkyne if you ask me.
It does indeed.
Hey, wait, for the bio majors in here, what kind of molecules or like what kind of,
It's a steroid one.
it is a. Good job.
Whoa, a big brain right here. Oh my
Y'all
God.
all knew that. Y'all all knew.
No,
that.
I didn't.
Dr.
IOL.
Anyways.
Wait,
Yeah,
that
the
means
correct answer
steroid?
is D,
Essentially.
because triple bonds, right, are the shortest bond. They're the strongest, but they're also the shortest.
Yeah, that's how you know, that's how you know it's a
I
steroid.
look at the name.
IOL, that means diol, it means there's two alcohols in this.
Oh, I don't know.
You know it from the structure.
Sounds like
Extra, like whatever, like extra, like estrogen, then you know.
that's what I did.
Yeah, estradiol, it's a steroid, because Dr. Perry said it. Yeah, one of them was.
All right, so the double bond is like pretty strong, but it's not like, it's pretty strong, but it's not, and it's like decently long. For B, right, you got the carbon-carbon single bond, that's your longest bond, but you're also your weakest. And then same thing with C, but D, right, is your shortest, but your largest in energy. Yeah, so that's why that's correct. All right. 24, which figure illustrates a pi bond?
So a sigma is just a pi bond is an S and a P hybrid.
Yeah.
But I don't know which one of these.
Pi?
Oh, B? No, it's A. No, I don't know. I don't know, Rich, which one is it?
That's what I got D.
Say your answer high with pride.
And B is.
Dude, it's these Dr. Aguilar students, you know who, was it Chris? It is Chris.
So.
One of my other students. Literally.
Wait, how is that D? That's
Because
D?
B is not a.
I mean, you
B is not a
remember what
pi
we talked about last time with our pi bonds?
I think B is
So basically, pi
Hybrid.
bonds, right, are formed through an empty p orbital. So there's an empty p orbital here and here. So they're caused by an overlap of the p orbital along its axis.
Remember, p orbitals, like pi orbitals or pi bonds, those p orbitals are not hybridized. They're empty p orbitals.
Oh, the door.
So you're not looking for a hybridized thing here.
So the other ones, they don't exist.
No, B exists.
This is just like hydrogen bonding, or I don't know what. the
No,
heck
don't
this
say
is.
hydrogen bonding.
Not hydrogen bonding, but like.
I
don't
know
know what the heck
I
this is.
see. Cause that's like.
This is
So
just-
everything that is a direct overlap of a bond is a sigma bond. You know, these are like direct overlaps right here.
So yeah, the A would
Does A
correspond to.
exist?
See how it makes that, what are those things called? The little things, the circle thing that you put the similarities in them. A Venn diagram. If you see a Venn diagram, that's a sigma bond, okay? If you see no Venn diagram, that's a clearly there's no direct overlap of orbitals.
Yes, B is a sigma bond.
Bro, there's a shit ton of. Oh my God. Yeah, dude, they're all in the trash. Bro.
Y'all were unmuted.
Oh, did he tell you that they tried to schedule this at 3 o'clock?
Excuse me?
Yeah, and I was like, nah.
No. It's not a fight with me.
Yeah.
All right, so correct answer is actually D. You got this overlap, the two overlap of p orbitals across their axis. Dylan said
Get out.
if you see a Venn diagram, it's sigma bond. If you don't see a Venn diagram, it's a pi bond.
It's just your UTSA.
Yeah.
The new
Jasper.
one.
You won the clown, whatever, I don't know.
All right, we're doing this last one then.
Which one?
30. Determine the number of valence electrons for the element already.
Ooh, I have to.
But I have a question.
Radium is.
So.
which one?
Acids, 70 plus 10.
You're such a nerd, Rich.
But then
Oh my God.
outer electrons are just the high
BK?
Highest
number. N equals.
So like for metals, outer electron.
It's just.
I mean, Michelle, you can type it in the chat.
Or F.
So usually for the
F2.
Yeah.
Outer.
And then for these main, give me ranks, the outer is equal to the valence, right?
Vanadium.
Vanadium,
Wait,
this
this is, no, never mind. I got it. Yeah.
is fine.
Watch the.
Oh, wait, 23.
What's the atomic number for LA?
LA. Let's go. 57.
Wait, what's the atomic number for DY?
I don't.
DY?
In 5 seconds.
60.
I like the lines.
60
I like the
seconds.
lines and
Oh.
I'm looking at
Hey, look at you, somebody hands. This is B.
I don't know.
Yes.
It's
Let's look at our famous periodic table. Right?
Yeah.
Iridium, right? So
Yeah.
you go right here.
Louder.
There's your two outer electrons, right? Then you got.
We have 3 minutes.
Right.
Thank you.
All right.
You're
So,
so rude.
all right. So
What did you say?
I just said we have 3 minutes.
What did she say?
She's like, are y'all done?
all right. Let's look at the hula actions. So we got one. Yeah. Hula. All right, let's look at part one. We got one for cesium, one for the barium, that's 2 electrons. And we got 3, 4, 5, 6, 7. Oh wait, I forgot one. 3, 4, 5, 6, 7, 8, 9. And if we go back. We go back, we got 1, 2, 9 of these, right? Just remember that the maximum is 12. So 12, the maximum will be a mercury, so just subtract 11, 10, 9, and then you'll get iridium, 9 valence electrons.
When y'all leave, can y'all pretend like you're in like P-Chem and be like, these O-Chem lectures do not need this much like tutoring, like P-Chem is harder. Just say that. Okay? 'Cause if
All right, yeah, and because the OCHEM students are outside, we're gonna call it.
So Michelle, for valence, for transition metals, you always count the D electrons and the S for valence.
Oh, wait.
But for outer electrons, you count the I energy. The S. Biggie.